of chapter 1 of science. In the previous part, we have learned chemical reaction is a process in which chemically new substances are formed from reactants. Chemical equations are just a representation of chemical reactions on page. Chemical equations are balanced so that law of conservation of mass should not be violated. And last, chemical equations are balanced by heat and trial method. Now, in this part of the video, we are going to learn combination reaction, decomposition reaction, exothermic reaction, endothermic reaction. There are several parts of types of the chemical reaction, but in this part we will learn these four. So first we will learn combination reaction. Combination reaction. As the name suggests, that in such type of reaction, the reactants combine, or two or more elements combine to form a single product. It would be like this one, A plus B, it will give C. So we can see here there are two components which combine to form a single component. So in a combination reaction, two or more components react to form a single compound. So such reactions in which two or more components react to form a single compound is called combination reaction. Now we will see few examples of this reaction. Calcium oxide, it is in the solid form, plus water, it is in the liquid form. These two when react will give calcium hydroxide, it is in the aqueous form. This is known as quicklime. Calcium oxide actually it is. This is known as quicklime. This is water, we all know it. And this is select lime. Here's select lime. Another example we will see, that is carbon plus oxygen. These two when burned together, it will give carbon dioxide. So in these two reactions we see that two components react to form a single component. Here as well two components are there producing single component. So such reactions in which two or more components react to form a single component are called combination reactions. Next reaction we are going to learn here is decomposition reaction. Decomposition reaction. Here as well, as the name suggests here, that in such reactions there is decomposition of the reactant to form a product. So such reactions would be like this one, a single component it will decompose to give two or more than two components. So here single component or single reactant will decompose to give two or more than two products. Or more than two products. Now we will see few examples of this one. That is decomposition reaction. First, iron sulfate in the crystal form, when heated, it will give iron sulfate solid and water in the gaseous form. So here the color is very important point. It is light green. It is the crystal form and the color of iron sulfate is white. It is solid. Now another example, iron sulfate when heated, we know its color is white. We have just seen its color is white. When it is heated, it will give iron oxide in the solid plus sulfur dioxide gas plus sulfur trioxide. It is also in the form of gas. Here color is also important, that this iron oxide has the color dark brown, and these two produces odor of burning sulfur. Must have felt during fire cracking. So during the fire cracking, a peculiar smell what you get there, what you feel there, that is actually the odor of burning sulfur. So during the heating of iron sulfate, we will get the peculiar fire cracking, we get peculiar fire cracking smell. Next example, calcium carbonate in the solid form. When it is heated, it will produce calcium oxide in the solid form plus carbon dioxide in the gaseous form. This calcium carbonate is also known as limestone, and this calcium oxide is known as quicklime or simply lime. So here again calcium carbonate is decomposed into two components, therefore it is decomposition reaction. Next example is lead nitrate. It is in the solid form. Again, when it is heated, it will produce lead oxide in solid form plus oxygen gas and nitrogen dioxide in the gaseous form as well. So this lead nitrate, when heated, it will produce this gas which has brown color. So this brown fume of nitrogen dioxide is produced in this reaction. So here we also get from one component more than two components. So it is also decomposition reaction. So up to here, up to 3, we have seen that up to third one in the previous page we have just seen that the decomposition is led by heat. So such reactions, such decomposition reactions which are led by heat are called thermolysis. Thermolysis. Here thermo means heat and lysis means breaking. Lysis means breaking and thermo means heat. So the reaction in which the breaking or the decomposition is done by heat is known as thermolysis. Another name is also of this one pyrolysis. Pyrolysis. The difference between thermolysis and pyrolysis is that in the case of pyrolysis, the heat is uh, greater than 3000 degrees Celsius. So it would be very high temperature. So if in a very high temperature the decomposition occurs, then that type of reaction is known as pyrolysis. But less heat is there, such as in these cases, then it is known as thermolysis. Now we will see next example, silver chloride. It is in the solid form in sunlight. It will be decomposed into silver plus chlorine. This chlorine is in the gas and this silver is in solid. Here color is also important. Silver chloride is of white color and silver is of gray color. The similar reaction is also of silver bromide. It is in solid form in sunlight. It will produce silver plus bromine in the gaseous form. Here also the color is important. It is white color and it is of course gray color. So this reaction was once used in the black photography. But nowadays it is not used because our photography technique has been digitized. So it was once used when a negative photo negatives were used. Then in the black photography, this reaction was actually taking place on that negative. In these two reactions, we see that the thermolysis is going on due to the presence of sunlight. Since the decomposition is taking place in the presence of sunlight, therefore these reactions are called photolysis. Photolysis. Photo means light and lysis means decomposition or breaking. So the decomposition reactions in which the decomposition occurs due to sunlight are called photolysis. Next example we are going to have here, that is the decomposition of water. It is slightly acidic, made acidic by putting some acid like HCl, and electric current is used here. Electric current is used in this reaction, and then we get hydrogen, it is in gas, plus oxygen, it is also in the gas, and here I missed that it is liquid. So what we see in this reaction, that the thermal decomposition is taking place due to electric current. So such reactions are called electrolysis. Electrolysis. So what does electrolysis mean? That electro means electric current and lysis means decomposition. So the decomposition reactions which take place due to electric current is known as electrolysis. This reaction is also very important for the examination point of view. In the examination, such questions are asked that in an experiment where the electrolysis of water is going on, there in one test tube we get twice volume than that of the other test tube. So what is the reason behind it? So the reason behind that is explained by this reaction, that during the electrolysis of water we get 2 moles of hydrogen while 1 mole of oxygen. Therefore the volume found in the test tube that contains hydrogen is twice that of the test tube containing oxygen. So this is the reason for having the volume twice in one test tube than that of the other during the electrolysis of water. Now next reaction we are going to learn, that is exothermic reaction. Exothermic reaction. So those reactions in which heat is evolved at the end of the reaction are called exothermic reaction. So heat is evolved here. Heat is evolved at the end of the reaction. At the end of the reaction. In this case, heat is evolved. So few examples are also there. Carbon, when burnt in air, it produces carbon dioxide plus a huge amount of heat. This heat may be written as Q. So since this heat is released here, therefore it is exothermic reaction. Another example is, this is CH4 methane. It is methane. When burnt in air, it will produce carbon dioxide plus water and of course much amount of heat. So due to the production of the heat at the end of the reaction, such reactions are known as exothermic reactions. So these are exothermic reactions. There are many such reactions, mainly the fuels are the exothermic reactions, and some common examples of the exothermic reactions are respiration, we all know about it, composting, we have also learned about this, mixing of water in acid, mixing of water in acid, it is highly exothermic reaction. Therefore we should not mix water in acid, rather acid in water. And one thing is notable in this case, that most of the combination reactions are exothermic reactions. Most of the combination reactions are exothermic. One exception we would like, there are actually several exceptions, but one exception we would like to put here as an example. Nitrogen plus oxygen, when produce nitric oxide, it is endothermic reaction, sorry. It is endothermic reaction. So this reaction is actually combination reaction, but it is exceptional, it is endothermic reaction. After this we will learn endothermic reactions. Endothermic reaction. Those reactions in which heat is absorbed at the end of the reactions are called endothermic reactions. So heat is absorbed at the end of the reaction. At the end of the reaction. So the reactions in which heat is absorbed is called endothermic reaction. Few examples we are going to observe here. The first is silver bromide. We have seen it somewhere. It will decompose into this way. It is endothermic reaction. Second of the same category, we have also seen it in the previous pages. It will give silver plus chlorine. Next example of the endothermic reaction, sodium carbonate plus acetic acid it will give sodium acetate plus carbon dioxide plus water. This reaction is also endothermic reaction. Few common examples are also there. Few common examples or day-to-day examples like photosynthesis, boiling of an egg, baking bread, these all are endothermic reactions. So most of the decomposition reactions are endothermic reactions. Most of the decomposition reactions are endothermic reactions. Endothermic reactions. But there is also an exception. This is hydrogen peroxide when decomposed. This one. This is exothermic. Exothermic reaction. So this is an decomposition reaction, even then it is exothermic. But most of the decomposition reactions are endothermic by nature. So in this chapter, what we have learned that combination of more substances to form single compound is called combination reaction, and decomposition of one substance to many compounds is decomposition reaction. If heat is evolved at the end of a reaction, it is exothermic reaction, and if heat is absorbed at the end of a reaction, it is endothermic reaction. Generally, decomposition reactions are endothermic while combination reactions are exothermic. In the next part of this video, we will learn displacement reaction, double displacement reaction, and redox reaction. So till then, stay subscribed